In the previous class, we discussed the nature of light. And we explained two different natures of light. We explained the electromagnetic nature of light and the particles nature of light. In this class, we are going to discuss the advantages of fibers. There are many advantages of fibers, but we are going to discuss the main advantages only. Fibers are made of glass, that is silicon dioxide, which is plentiful. So if the material is plentiful, definitely this material will not be costly. The price of the material will be low. Some fibers are made of transparent plastic, and this is another readily available material. Fibers have greater information carrying capacity than do metallic cables. For long paths, fibers are cheaper to transport and easier to install than metal cables. And the reason behind it is that fibers are smaller and lighter. So we are going to explain, this statement with the help of this example. Let us compare a fiber cable with a coaxial cable. So we are going to discuss the specification of the fiber cable first. The diameter of the single fiber in the fiber cable is 125 micrometer. This is the diameter of a single fiber. And the overall diameter of the fiber cable is 2.5 millimeter. Weight of this fiber cable is 6 kilogram per kilometer. And loss of the light signal in this fiber cable is 5 dB per kilometer. Let us compare this fiber cable with RG19/Q coaxial cable. The overall diameter of this cable is 28.4 millimeter. So if we look at the previous slide, the overall diameter of the fiber cable was 2.5 millimeter only, and the diameter of this coaxial metallic cable is 28.4 millimeter. Very large as compared to the diameter of the fiber cable. Weight of this coaxial cable is 1110 kilogram per kilometer. You see, weight of the fiber cable was 6 kilogram per kilometer, while the weight of this cable is 1110 kilogram per kilometer. So you see, the coaxial cable is very heavy as compared to the fiber cable. Loss of the signal in the coaxial cable is 22.6 dB per kilometer. So if we compare it with the loss of the light signal in the fiber cable, you see loss of the light signal in the fiber cable was 5 dB per kilometer, and this loss is 22.6 dB per kilometer. So you see, is the weight of the fiber cable is 6 kilogram per kilometer, and the weight of the coaxial cable is 1110 kilogram per kilometer. This is why we say that for long pots, fibers are cheaper to transport and easier to install because fibers are smaller and lighter. Now, the loss in the optical fiber is almost negligible as compared to the losses in the traditional metallic cables. This is the conclusion as well. You see, if we compare the loss in the optical fiber with the loss in the metallic cable, the loss in the fiber cable was 5 dB per kilometer only, and the loss in the metallic coaxial cable is 22.6 dB per kilometer. So nowadays, fibers having very low losses have been designed. Anyhow, there are no great differences in the operation of fiber or metallic system. So there is no difference in the operation of fiber or metallic system. The cost here should be the same. Maintenance of fiber cables does differ. If a line is broken as a result of either an accident or a system modification, splices must be made or new connectors attached. These operations require more time and skill for fibers than for wires. As a result, maintenance costs should be considered when designing a system in which many changes are likely to be made. Surprisingly, fibers are very strong and flexible. As losses in the optical fibers are negligible, so large communication links can be constructed without installing amplifiers. So we conclude that less number of amplifiers are required in fibers as compared to metal cables. This is another advantage of the optical fiber as compared to the traditional metallic cables. We need less number of amplifiers in the fiber optic communication system. Fibers can transmit large amount of information from one place to another place. And let us explain the information carrying capacity of the optical fiber with the help of the following example. We compare a telephone cable with a fiber cable in this example. So let us consider the telephone cable first. The diameter of the telephone cable is 70 millimeter. This is the overall diameter of the telephone cable. That is 70 millimeter. This metal cable consists of 900 twisted wire pairs. So there are 900 twisted wire pairs in this telephone cable. Each wire pair supports T1 rate. Each wire pair supports T1 rate. And what is T1? That is 24 wise channels per wire pair. So we can find out the information carrying capacity of this metal cable. There are 900 twisted wire pairs, and each wire pair supports 24 wise channels. So the total capacity will be equal to 900 multiplied by 24, which is 21,600 calls simultaneously. So the information carrying capacity of this metal cable is 21,600 calls simultaneously. Now let us talk about the fiber cable which is used for telephonic conversation. So we talk about the telephone fiber cable. The overall diameter of the cable is 12.4 millimeter. If we compare it with the overall diameter of the metallic cable, the overall diameter of the metallic cable was 70 millimeter, while the diameter of the fiber cable is 12.4 millimeter only. So this cable is smaller than the mentioned metal cable. And this cable contains 144 fibers. There were 900 twisted wire pairs in the metal cable, while here we have only 144 fibers. Each fiber in this cable supports T3 rate. And you see what is T3 rate? 672 voice channels per fiber. So a single fiber in the cable can carry 672 voice channels. So we calculate the information carrying capacity of the metal cable. There are 144 fibers in the cable. A single fiber in the cable supports 672 calls, 672 channels. So the capacity comes out to be 96,768 calls simultaneously. So this is why we say that the information carrying capacity of the fiber cable is far better than that of the metallic cable. As fibers are insulator, they do not pick up any electromagnetic pulse. They do not pick up electromagnetic pulses. And the electromagnetic pulses are caused by nuclear explosions. And these electromagnetic pulses can induce millions of volts in a conducting transmission line. So, as fibers are made of insulator, these pulses cannot induce millions of volts in this transmission line. And you see, the voltage pulse can travel many miles along the wire, and eventually, because of its strength, it can destroy the electronics at the end of the path. So this is another fiber, another advantage of the optical fiber. This is another advantage of the fibers, that these fibers are made of insulators. They do not pick up electromagnetic pulses, and as a result, you see, the electronics equipment at the end of the path will be safe. As fibers are insulator, no current flows in these fibers due to the transmitted signal. We know that the signal in the fibers are in the form of light. There is no current in the fiber. The light signal travels from one point to another point in the fiber, from one place to another place in the fiber. So no current flows in these fibers due to radiation as well. No current flows in these fibers due to radiation because these fibers are made of insulators. So we can say that fibers reject radio frequency interference and electromagnetic interference. Radio frequency interference does not take place in fibers, and electromagnetic interference does not take place in fibers. What is radio frequency interference? Radio frequency interference is caused by the signals generated by the radio stations, television stations, radars, and other electronic equipments. What is electromagnetic interference, EMI? Electromagnetic interference is caused by natural phenomena such as lightning, and electromagnetic interference is also caused by sparking. So we conclude on the basis of this discussion that fibers reject noise. This means the signal to noise ratio in the fibers is very high. The quality of the signal will be very high. SNR of the signal will be very high. No crosstalks occur in a fiber cable. Fibers offer degree of security and privacy. They do not radiate the energy, so an outsider cannot receive the transmitted signal. It is very difficult for an outsider to receive the transmitted signal because the fibers do not radiate energy at all. If an outsider wants to detect the signal, if an outsider wants to receive the signal, he will have to break the fiber first and then fuse another fiber to the transmitting fiber, and this job needs a technical hand. This is not an easy job. Everyone cannot do it. The corrosion caused by water and chemicals is less severe. Fibers can withstand high temperature. So these are the main advantages of the fibers. Now let us do a numerical example. This is question number 1.6 from the exercise of chapter number 1. You see, this question says that RG 19/U is used at 100 megahertz with an input power of 10 milliwatt. The receiver sensitivity is 1 microwatt. Compute the maximum length of the communication link. So this is the first part of the question. In the first part of the question, we need to calculate the maximum length of the communication link if we use this coaxial cable. Then the second part of the question says, if a fiber with a loss of 5 dB per kilometer replaces the coaxial cable, then what will be the maximum length of the fiber for this communication system? The fiber system's input power and receiver sensitivity are the same as those of the coaxial cable system. So let us do this numerical question. You see, we consider the coaxial cable first. This is the first part of the question, and in the first part of the question, we consider the coaxial cable. You see, this is the loss per kilometer in this coaxial cable when it is operated at 100 megahertz signal. So the loss per kilometer of this coaxial cable is 22.6 dB. The input power of the coaxial cable is 10 milliwatt. The output power of the coaxial cable is 1 microwatt. We calculate the total loss of the coaxial cable in decibels. And we calculate the total loss of the coaxial cable in decibels with the help of the second last equations. So the total loss will be equal to 10 log of P2 by P1, where P2 is 1 microwatt and P1 is 10 milliwatt. So we put the values of P2 and P1 in the second last equation. So the total loss in the coaxial cable is 40 dB. So we can calculate the maximum length of this communication link now. We know that 22.6 dB loss occurs in 1 kilometer length. So 40 dB loss will occur. We calculate, you see, we simplified. We have 40 multiplied by 1 divided by 22.6, that gives you 1.77 kilometer. So maximum length of the communication link is 1.77 kilometer. Now we consider the second part of the question. If we use an optical fiber, if we replace the coaxial cable by an optical fiber, so the input power of the optical fiber is 10 milliwatt. The output power of the optical fiber is 1 into 10 raised to power minus 6. We calculate the total loss with the help of this equation, that is 10 log of P2 by P1. We put the value of P2, we put the value of P1. We have already calculated the total loss in the previous case, and the total loss in the previous case was 40 dB. So the total loss in this case will be 40 dB as well. Why? Because the input power is the same and the output power remains the same. So loss in fiber per kilometer is 5 dB. 5 dB per kilometer is the loss of the fiber. So 5 dB loss occurs in 1 kilometer length. Definitely 40 dB loss occurs in 40 divided by 5, that is 8 kilometer. So maximum length of the fiber link will be 8 kilometer. So we discussed the advantages, main advantages of the optical fibers in this class. We discussed one numerical questions. Inshallah, I will upload the homework in a few days. Thank you so much.